So, very warm good afternoon and welcome to you all under NAP Caste Training Program. So, today's speaker is Dr. Veda Krishnan. So, first I would like to welcome Veda with a flower. Thank you. So, Veda Krishnan, she is a young budding scientist working in the area of starch quality, and she have lot of projects and published several papers in high impact journal. So, she is a very active young dynamic scientist, and today she will take practical on amylose estimation and amylolytic activity. So, Veda, please. Thank you.
A very good afternoon. So, welcome back. So, today we are going to do two very important practicals, that is amylose estimation and amylolytic activity. So, before getting into directly on the practicals, the methodology and the principle, first let me enlighten you that why you are going to do this practicals, because that is more important. I hope that yesterday Dr. Archana Singh had a elaborate lecture on starch value addition, and I hope that you all go translate that what is the need of starch in the current scenario, and the term starch dilemma, right? Starch dilemma. So, because of n number of studies, we got to know that the carboholic diet, that is the staple cereal rich diet, and with your sedentary lifestyle, now it is moving towards more into the pandemics like lifestyle disorders, what we are seeing nowadays. There is a lot of like metabolic syndromes, diabetes, your type 2 diabetes, obesity. So, all these things are associated with your type of the diet that you are taking. So, that is why now the new generation is moving towards less carb diet, low carb diet or no carb diet, your keto diet and all those things. So, why this cereals or starch containing molecules are a culprit? So, that is very important to understand. So, you all had your lunch. Okay? So, let me tell you that is what is happening in your body right now or for the next 4 hours. Okay? So, if you see through a biochemist's eyes, I can see that you had your lunch which is full of carbohydrates, might be protein is also there, but carbohydrate is your major thing. So, there is a rapid spike of glucose from 30 minutes to 240 minutes. Okay? And if you are taking a carboholic diet, that is lot of white rice and all, this spike is so high, okay, within 120 minutes, most of the glycemic response is happening. Okay? So, this spiking is causing lot of oxidative stress in your body. And whenever there is an oxidative stress, you know what is happening? Free radicals are released. And whenever free radicals is there is an oxidation to the biomolecules. Protein oxidation, lipid peroxidation, DNA oxidation, even your glucose molecules, your sugar molecules are also getting oxidized. Have you heard the term AGE, advanced glycation end products? If you have gone through any aging kind of studies or these kind of cancer studies, now these are very important terms. Your membrane sugars are also getting oxidized. So, oxidative stress is a very important problem. So, this glycemic response, what you are because of your diet, is causing an oxidative stress, and because of this oxidative stress, there is lot of oxidation to your biomolecules, DNA, protein, lipid and everything. Because of that, many metabolic fluctuations is happening in your body. Because of those fluctuations, we are seeing there is a trend of increase of these lifestyle disorders. Okay? So, what we have to do? We have to have certain kind of a diet. So, this is called glycemic response. But there is also a term called glycemic index. Index is always a ratio. Okay? So, when you compare the glycemic response of your food product with a pure sugar, then you get a ratio. So, that ratio is called glycemic index. So, for any polished rice, the glycemic index is always more than 70. It is a high glycemic commodity. Okay? So, rice, your wheat, these are all considered as highly glycemic. That means a very sharp response is going to happen in your body. But now people are trying to engineer new products where your glycemic response is going to be like this, from 30 to 240. Can you see a spike here? No. It is a slow and sustainable release of sugar. Now it is happening in your blood. So this is called extended glycemic index. Okay? And this type of a glycemic response, yesterday you might have heard the word resistant starch. Okay? So this type of molecules, starch molecules, if there is in your food product more, then you will get this kind of a glycemic response. So we normally say physiologically starch can be divided into three: rapidly digestible, slowly digestible and resistant starch. If your food is rich in slowly digestible starch and resistant starch, then definitely you are going to get this kind of a glycemic response, which is not creating any oxidative stress in your body, and that is good for your metabolic health. Okay? So now you understand starch quality is very important. Now why amylose? What are the components of starch? Amylose and amylopectin. And what is the difference between both of them? Yes, amylose is a linear chain. You have an alpha 1,4 linkage, and amylopectin is a branched molecule. And amylose, even though we say it's a linear chain, it exists as a left-handed helix, B type. Okay? So it exists as this kind of a helical molecule. So its inner hydrophobic region can accommodate lot of guest molecules, hydrophobic molecules like fatty acids, molecules like iodine. Okay? This can get and trap into these amylose. You might have a resistant starch type 5. Type 5 means amylose with fatty acids. Okay? These are the combinations because of your amylose structure. And this same principle is used for today's practical, that is amylose estimation. So we are using a very simple colorimetry method, or you can use a spectrophotometry method, in which you are adding iodine molecule which will bind to your amylose, which into the intra region, so that now it is amylose iodine complex. Now it will give a deep blue-black color, which you can determine around 620 nanometer. Otherwise your amylose is colorless, so you need some color reagent which you can tag with your amylose, and now which you can determine by your spectrophotometric method. So this is the one that we are going to do today. But before that, amylose can also be done by different method. Okay? So a very simple method, if you have to go back to your institute, where you have to screen lot of molecules, lot of varieties with amylose. Okay? You have to screen them based on amylose, then you cannot go for these kind of assays. So the very simple method is called endosperm staining. Okay? Just you have to imbibe your seed, cut it, okay, then you get 2 halves. Just put a drop of iodine, 0.2% iodine. Just 0.2% iodine you will add, then you will see a change of color from reddish to blue based on your amylose content. For example, if there is 3% amylose, you will see a red color. If there is a 15% amylose, you will see a light blue. And when it's a 30%, you will see a bluish black. Okay? So as amylose concentration increases, you can see there is a difference in the color. So this is a qualitative method. By visually you are seeing what might be the range of amylose in your staple cereals. You can do in rice, you can do in wheat, okay? All these bold grains you can do. But here you are not quantifying exactly. It is just to screen from a big population. But if you have to find out the exact content of amylose, then you have to follow today's practical, which is using iodine. Okay? So what is this iodine method? So iodine as a molecule is slightly soluble in water. Okay? Very slightly soluble. So you all know whenever there is an two similar kind of an atom, so there is always a high electronegativity. So it cannot form a hydrogen bond with water. So always it is less soluble. But you need to make a iodine solution. In school you might have done starch test. So what you add on it? Iodine solution. That iodine solution is called Lugol's iodine, if you remember. That iodine solution is not only iodine, it is iodine plus potassium iodide. Right? Okay? Because alone iodine, it will not dissolve, it will only exist as I2 minus when it ionizes. But when you add potassium iodide, it will become K plus and I minus. So this will add with this, and now it is I2 minus plus I minus, so it is I3 minus. That is triiodide ion. Now this is very much soluble. Okay? Then only it can bind to your amylose. And when it is binding to your amylose, now it is a complex, and you can read the complex using 620 nanometer in a spectrophotometer. So this is the principle of your assay. Okay? But there are few precautions that you have to see. One is, what is your sample? If your sample is lipid rich, you have to defat it. If it is polished rice, there is very less lipid, so you can do without defatting also. Today's sample is a polished white rice. But if you are working on millets, which has a higher proportion of lipid, you have to defat it. And the second tricky part is the preparation of your iodine reagent. Okay? So iodine and potassium iodide should be 1:10 ratio. 2 gram iodine, 20 gram potassium iodide. Okay? And then you have to mix it. You have to keep overnight shaking. Then only, because already it is very less polar. So you have to need an extra force to make it more soluble. And you have to see whether the whole iodine is dissolved properly or not. Otherwise, the percentage of iodine, what you are expecting and what you are getting is different. Okay? So you have to make fresh iodine preparation, like maximum you can use for a week. And then you have to filter it so that there is no iodine undissolved that is left in your solution. Okay? Once you have all these things, then you can start your amylose estimation assay. Okay? So can we now move to the methodology part? So today what you are going to do is, here we will discuss the methodology, and the exact thing what you are going to do you will see in the lab. So we are going to take the sample, which is a polished rice. So you know rice, in the matrix of rice there is a starch, there is less protein, there is very less lipids and fatty acid and other thing. Okay? So from this matrix you have to break the matrix and you have to release your amylose. Then only it can bind to your iodine. So what you can do is, you can treat with NaOH and ethanol, which will increase the solubility of your sample. Then you have to boil also. Okay? So add NaOH, very high alkali, 1 normal NaOH, add ethanol, you boil the sample, okay, so that the whole sample is now highly soluble in your water. Otherwise you will always see a white precipitate. Okay? Now once your sample is solubilized, now what you can do? Now before adding your iodine, you have to neutralize the pH, because now NaOH is there, okay, it is highly alkaline. So for neutralizing, you have to add acetic acid. If you are adding 1x acetic acid, that means 1 ml acetic acid, then you have to add 2x iodine solution. Okay? So that is the ratio. I am not telling the volume, it is the fold. If you are adding 1x, you have to add 2x. Okay? And after adding iodine, the complex that is going to form is highly unstable in presence of light. So you have to cover with an aluminum foil, or you have to keep it dark. Okay? So that is the second thing that you have to be very careful. And then exactly after 20 minutes. Okay? And this also, it's very tricky, because in some commodities or food products there might be highly amylose. So then the blue color will be coming very fast. So this part you have to optimize a bit, but today we are keeping for 20 minutes, and after 20 minutes you will see the gradation of blue color, and then you can take the reading at 620 nanometer. Okay? So this is the methodology that we are going to follow, and to quantify it, along with that, simultaneously we are also going to do a amylose standard curve. Okay? Pure amylose, which we procure from Sigma. So we are taking it, and from 0.2 gram to 4 gram, we are having a standard curve. So you all know the basics of standard curve. What is the need of a calibration curve for accurate quantification? So where you will get different OD values, which you will plot. So this is always an OD versus concentration graph. So you get a linear graph which has a equation of y is equal to mx plus c. From that you will calculate your unknown concentration. That is just like for any normal biochemical assay. Okay? So this we will do in Excel in the lab, and we will show you that how you can calculate your own sample after going back home. Okay? So this is one part of the practicals that we are going to do. So we also have to do another practical, that is amylolytic assay. So what do you mean by amylolytic? Something that is lysing amylose, or we can say amylase inhibition assay. Okay? We can also, so I want to, like, as a biochemist, I will be like to say it is an amylase inhibition assay. Okay? So amylase inhibition assay today you are going to do, in which what we are doing is, again, what is the importance of this assay? See, our job is to reduce the glycemic response. So whenever you eat your food, here glycemic response is happening. So I want to reduce it. Now you can select a starch which is already rich in slowly digestible, resistant starch or high amylose, so that the digestion and the sugar release will be less. That is one thing that we are going to do. The second aspect is, so what is degrading your carbohydrate? These are the carbolytic enzymes. What are the carbolytic enzymes? Amylase and glucosidase, amyloglucosidase. So first your starch is converted to maltose or maltotriose by amylase, and later maltose to glucose by your glucosidase. Okay, these are the two enzymes. So most of the anti-diabetic drug, we all know people are eating, okay, those drugs are all these amylase and glucosidase inhibitors. So that if you take that drug, whatever diet you take, that is inhibiting the enzyme, so that less glucose is released in that particular patient's body. So the same thing, but we cannot go for the synthetic medicine for long term. So we need some natural alternative for this. So we were in search of that, and we explored the pigmented rice for this. Okay? Have you seen pigmented rice? The black rice, the red rice. Okay? So the white rice, normally with the bran we call it as brown rice. Brown rice also has phenolics in the bran. But the pigmented rice has another spectrum of phenolics. Okay? They have anthocyanin, they have proanthocyanin, which are very good as amylase and glucosidase inhibitor. So today we are going to use the phenolics and treat with the pure amylase and see how much it is inhibiting these particular enzymes, so that we will get to know that which rice is good for the diabetic population. First is starch quality, and second is if the phenolics is there, definitely it is going to release less sugar. Okay? So that was the thought behind these assays and optimizing them in our lab. So for this there is two steps. One is phenolic extraction, which is really 2-3 days step. So we already isolated the phenolics for you. So if anybody is interested to know how you can extract the phenolics, you can get back to me so that I can give you the protocol. Okay? So today already the phenolics are extracted and we have the phenolics with us. So today what we are going to do is, we have pure amylase enzyme from Sigma. Okay? So we are treating the amylase with phenolics, amylase enzyme plus phenolics, and we are expecting that the phenolics is going to inhibit the amylase. So now the question is, how the phenolics is inhibiting the amylase. So whenever you take any food which is rich in phenolics, there are different methods in which they inhibit the enzyme. So whenever there is enzyme inhibition, the first thing is it might be binding to its active site. Okay? So the phenolics also similarly bind to the active site of these enzymes. And then once it is bound to the active site, they cannot do the normal job of converting the substrate to the product. Okay? Second thing is, this phenolic acid reduce the pH. So when pH is also reduced, the enzyme has an optimum pH. If it is not there, then it cannot do the job. The third is, all these phenolic acids are heteromers and polymeric structures. So what they can do is, they can cover your starch molecules with the phenolics, so that your enzymes cannot come and reach them. Like your starch is trapped with these phenolics. So there are different mode of action for this. So amylase is inhibited by the phenolics. So now we want to see which phenolic is more inhibiting the amylase action. So for this particular assay, we are extracted the phenolics. Now we are treating with the amylase enzyme for 30 degrees Celsius for 15 minutes. Okay? We are giving the time so that now phenolics is binding to the enzyme. Now to see that, we are adding 1% starch solution. Okay? So if the enzyme is inhibited, now the starch cannot be converted into sugar. So we are expecting the sugar release will be less here. To detect that, we are using a color reagent called DNS, dinitrosalicylic acid. This is the principle. So if phenolics is there, it will inhibit more. If phenolics is not there, so we have a control in which you are just adding enzyme only and with a solvent in which your phenolics is dissolved. For our case, it's DMSO, sometime it is methanol, whatever. So it's a blank solvent plus same starch, same DNS. Okay? So here your enzyme is not inhibited, so we are expecting sugar release will be more here. Here, because of inhibition, sugar release will be less here. So then you also have a blank in which your enzyme is not there, so that there is no sugar. Okay? So you have 3 different tubes. One is test, this is negative control, and one is your blank. Okay? On this basis, you can calculate the inhibition percentage. So what will be inhibition percentage? The negative control, which is having maximum absorbance of negative control, minus test by negative control into 100. Negative control means in which phenolics is not there. Maximum absorbance will be for that. Okay? Minus test in which phenolics is there. Okay? Divided by negative control into 100. In this way, you can calculate the inhibition percentage of your particular phenolic. And if you can identify some rice varieties which can inhibit for more than 80 to 90% of the enzyme, that means if you are eating that particular rice, it is good for the diabetic people, so that we can say that we can enrich the menu of the diabetics. They can eat rice very safely. It's going to be okay in their diet. Okay? So the ultimate objective of these 2 assays is to screen some varieties. We are working on rice, but we can also screen other varieties, millets or wheat, which is low in glycemic response. Okay? So that is the ultimate objective of this particular 2 practicals. So if you have any doubt, you can ask me, or else we can proceed to the lab work.
Thank you, Veda, for such a nice explanation. You very nicely explained both the practicals, amylose estimation and amylolytic activity. So for practical, we will move to lab. But before that, I please to felicitate Veda with Momento.
Thank you.